So now we're going to be dividing radicals, and to do this, our first problem is going to be rad 15 in the numerator, and in the denominator we're going to have 5 rad 20. Now you can simplify rad 20 right now, but though we decided to wait and simplify later. So you can't have a radical in the denominator, so you have to cancel out the denominator, and to do this, you're going to multiply by rad 20 on the top and bottom. So now we're going to be multiplying the top in the numerator, rad 15 times rad 20, and that equals rad 300. And in the denominator, we're going to be multiplying 5 rad 20 times rad 20, and that cancels out rad 20 to regular 20 times 5, which equals 100. So now what we're going to have to do is simplify the rad 300, and that's going to go into rad 100 times rad 3. And then the denominator stays 100. So now rad 100 is going to cancel out into 10, and rad 3 cannot be simplified. So you're going to have 10 rad 3 in the numerator, and in the denominator we're going to have 100. But we can simplify this even more because 10 over 100 equals 1 over 10. So we're going to be remaining with rad 3 over 10, and that is your answer. So now we're going to try another problem. So we're going to do rad 4 in the numerator, and rad 4 is going to be over 5 rad 3. So we're going to do the same thing as we did in the last problem by canceling out the denominator and multiplying rad 3 by the top and bottom. Now you're going to multiply rad 4 times rad 3, and that equals rad 12, and 5 rad 3 times rad 3. Rad 3 times rad 3 makes 3, so 3 times 15 equals 15. So 12 can be simplified more into rad 4 times rad 3, and rad 4 is a perfect square of 2. So we're going to be left with 2 rad 3 in the numerator all over 15, and that is your final solution. So now this next problem is going to be a little more challenging. We're going to do rad 15 xy over 3 rad 10 xy to the third power. So now what we're going to do is cancel out the denominator by multiplying top and bottom what's in the radical. So rad 10 xy to the third on the top and on the bottom. So now what we're going to be doing is just multiplying all the radicals together. So in the denominator, we're multiplying 3 times rad 10 xy to the third times rad 10 xy to the third. And that makes 3 times regular 10 xy to the third, because when you multiply 2 of the same radicals, it cancels out. So now we're going to be multiplying the numerator, and that's going to be rad 150, because you're just multiplying the radicals together, x to the squared, because x times x is x squared, and y to the fourth, because y times y to the third is y to the fourth. On the bottom, that's just going to make 30xy to the third simplified, and on the numerator, what you're going to want to do is simplify that even more. So rad 150 goes into rad 25 times rad 6.
And which one sounds better? What lies on its back 100 feet in the air?
And then we're going to keep x squared times rad y to the fourth. So now rad 20, this answer to rad 25 is just 5, and rad 6 cannot be simplified anymore, so we're going to leave that. Rad x squared equals x, and rad y to the fourth is going to just equal y squared. Y squared. So then our denominator is going to remain the same with 30xy to the third. Now we're going to need to continue to simplify this. So first we're going to combine the like terms or everything that's not under a radical sign. So 5xy squared times rad 6, and the denominator is going to remain 30xy to the third. So to simplify this even more, 5 over 30 simplifies 1 over 6, and the x's are going to cancel out on the top and bottom. And what you're going to do is subtract y squared, since it's in the numerator, minus y to the third. So we're going to start with 1 over 6, like I mentioned previously, because 5 over 30 is going to simplify to 1 over 6. We're going to cancel out the x's because they're on the numerator and the denominator, and they have the power of 1. And y squared minus y to y squared minus y to the third power is going to equals y to the negative 1 power, and you can't have a negative 1, so you're going to flip it down to the denominator, and rad 6 is just going to remain in the numerator, and that is your solution. Rad 6 over 6y. Now we're going to learn how to conjugate radicals. Now, when dividing, this is very important and is commonly used. So we're going to start with equation 2 over 3 plus rad 5. So since 3 plus rad 5 is a term, you cannot just multiply by rad 5 because you cannot separate the term. So you have to multiply by its conjugate, which is 3 minus rad 5. And you're going to do this like you did on the other problems, on the top and on the bottom. So here we go again, multiplying both on top and bottom with 3 minus rad 5, because that is the conjugate of 3 plus rad 5. So we're going to multiply 2 times 3 minus rad 5 on the numerator, and we're going to have to FOIL 3 plus rad 5 times 3 minus rad 5. So here we go. On the numerator, we're going to distribute 2 times 3 and minus 2 times rad 5. So that's going to equal 6 minus 2 rad 5. And we're going to FOIL on the bottom, and we're going to get 9 minus 3 rad 5 plus 3 rad 5 minus 5, because rad 5 times rad 5 equals 5. So now we're going to simplify even more. 6 minus 2 rad 5 cannot be combined, so that's going to remain the same on the numerator. And we're going to simplify minus negative 3 rad 5 plus 3 rad 5 is 0, so you're going to combine 9 minus 5, and that equals 4, which is what you will be leaving in the denominator. You can simplify this even more because 6, 2, and 4 are all factors of 2, so you can do a real-life example would be artists and architects who use golden rectangles to create the famous art that they are known for. They are most common seen in the Parthenon in Greece. The ratio of the lengths of the sides of a golden rectangle is 2 over rad 5 minus 1. And in this lesson, you learn how to simplify radicals expressions such as 2 over rad 5 minus 1.